Solving simultaneous equations involving no multiplying with adamonlinetutoring. This is the beginner question involving some access to the slightly harder ones. The first thing we'll want to do is make sure that the coefficients of these terms highlighted are the same. The coefficient is the number which goes in front of the algebraic part. In this case, the coefficient of both of these terms y would be 1. Now that we can see that they're the same, we move on to the next step, which is looking at the signs attached to them and determining whether they're the same or whether they're different. If they're the same, we'll be able to eliminate these terms by subtracting one equation from the other. Therefore, we would say or use same signs subtract, or for short, SSS. If the signs were different, a plus and a minus, we would use different signs add to eliminate the terms instead, or for short, we would call this DSA. In this case, because the signs are the same, we'll use same signs subtract. It doesn't matter what equation you subtract from the other, we just need to stay consistent as we go through. For this question, it makes sense to take away the bottom equation from the top one, because all of the numbers at the top are bigger. So looking at the first two terms, 5x take away 2x will leave us with 3x. Looking at the next terms, y take away y would be 0, or will cancel, there's nothing. We don't need to worry about doing this each time. The whole reason we do different signs add or same signs subtract is to eliminate these terms. So as long as you've done that first step correctly, then these terms will always just cancel out. And that would be equal to 20 subtract 11, which is 9. Therefore, 3x equals 9. X must be equal to 9 divided by 3, which is 3. Once we know what x is, we can substitute it into one of the original equations. It doesn't really matter which one. I try and go for the one which has a positive in front of the terms, as that tends to make it a bit easier to solve. But in this case, they're both positive, so it really doesn't matter which one we substitute into. I'm just going to substitute x into the second equation. We have two lots of x. We know that x is 3, so 2 lots of 3 is 6, and 6 plus y is equal to 11. So therefore y must be equal to 11 minus 6, which is 5. Slightly harder with the intermediate question. Looking at the signs, we can see they're different. So this time, to eliminate those terms, we're going to use different signs add. 3x plus 4x is 7x. As I mentioned previously, these will just cancel by adding the equations together, which is what we're doing. And that's equal to 2 plus 12, which is 14. If 7x is 14, x would be equal to 14 divided by 7, which is 2. Substitute this back into one of the original equations. My preferred is always the one that has a positive in front of the term you're trying to find. So this one, the first one. 3 lots of x, or 3 lots of 2 is 6. 6 plus 2y is 2. Subtract 6 from both sides, so we get 2y is equal to negative 4. And then we can divide by 2 on both sides, so we end up with y is equal to negative 2. Lastly, we have the advanced question. Notice how the coefficient of these terms are already the same. So looking at the signs attached to them, I can see we're going to need to use different signs add to eliminate them. 3x plus 7x is 10x. The y terms will cancel, and 7 plus 13 is 20. If 10x is 20, x would be equal to 2. Substitute this back into the one that has a positive in front of 2y. 7 lots of x, 7 lots of 2 is 14. 14 plus 2y is equal to 13. Subtract 14 from both sides. 2y is equal to negative 1. And then we can divide by 2. So y would be equal to negative 1 over 2, or negative a half. To check your answers, we can substitute the values that we found, x is 2 and y is negative a half, into the original equations. So we would substitute 2 into here, and negative a half into here and here. And when you work those out, you should end up with 7 and 13. If you don't, you know you've done something wrong, so you can go back and do it again. Normally the biggest mistake is people have subtracted the equations when they should have added, and vice versa. Before you go, have a little look at my solution for a question similar to the intermediate one. I may have made some mistakes. See if you can pause the video, identify those mistakes, and comment what they are or the corrections below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.